Dictian Cummings need.
Hi guys, welcome to my channel. In this video, let's discuss about the concept of RF protection and how to test it practically at site. Although there is differential protection for protecting the transformer windings, what is the need for RF protection? Since differential protection setting is usually around 20% to avoid errors caused due to CT and during tape changing, etc., differential protection cannot protect its winding 100%. So if fault current is below 20%, it can't provide protection even for internal faults. So for this reason, we are using RF protection with lower setting. Let's see the basic scheme of RF protection. A set of phase CT is parallel and connected to neutral CT, across which relay coil is connected with stabilizing resistor and metro cell. Stabilizing resistor is used in series to prevent the operation of relay in case of through fault, or which is otherwise called fault outside the zone of protection. Metro cell is a non-linear resistor in which electrical resistance depends upon applied voltage. It is connected in parallel with a relay circuit to limit the secondary voltage of a CT to a safe level during maximum internal fault conditions. Let's see the working principle of RF protection. Let's say fault occurs outside the zone of protection. Fault occurs somewhere here, that is R phase is earthed. The fault is here, so the flow of current will be towards the fault. Since R phase is earthed, there will be a flow of current in neutral also. That is, current enters neutral through P2 terminal. Since primary current enters through P2, it leaves the secondary terminal through ES2. So the flow of current will be in anti-clockwise direction. Here the current flows towards the fault, that is, enters through P1 and leaves through S1. So the flow will be like this. Since phase CT and neutral CT currents are opposite to each other, there will be no flow of current in relay coil and the relay is inoperative for through faults. So let's see how the flow of current will be for in-zone fault. Say I have drawn this. Exactly, the fault occurs in the in-zone, means the transformer secondary part, it's somewhere it is some fault occurs. So what will the current flow will be from? There will be only current flow in the current only will be flow in the neutral CT. So relay operates for in zone fault. This is its protection zone is this only. Its protection zone is RF protection zone is this only. So it will operate immediately as soon as it senses the relay senses a fault in the in zone. So how to check this RF protection practically? So first we are going to check the stability of the RF protection. As I said, I have drawn already this drawing to reduce duration. So if you do not watch our if you do not know how to calculate short circuit current, just watch our previous video, or if you know, just listen. So we are going to apply here 415 voltage in the primary side of the so applying delta side. Okay, next what we are going to do, we are going to short, we are going to earth any phase, we are going to earth any phase, say this I am earthing. So automatically what we'll do, so I am shorting with the cable, I am earthing it, I am going to earth this one. Okay, so when I apply 415 voltage, since it is here, the current will flow through this, so flow will be here, this current will flow be here, then so since this is S1 S2 S1 S2, here the current flow will be like this, so I want to consider this I1, here the current flow will be like this. So this one equal to I2, so I1 plus I2 equal to 0, so I1 plus I2 equal to 0, so no flow, there will be no flow, sir, there will be no flow in the since this phase CT and neutral CT cancels each other, there will be no flow in the relay, and we will not operate it. Make sure to connect the proper by noting the capacity of the primary current and the short circuit current. You have to put the looping cable like that, or if you have this okay, this one is stability, or we can do this in another way. Let's check how to do it. Same way we are going to do this. Okay, again the same way on if you have earth switch at this end, if you close this earth switch, then automatically the flow of current, the current will flow through this way. Again here it is this, there will be no fault. Okay, here at switch, this is another way of doing stability, say in case if not, so there will be no operation of relay. Again, so or you can short it. If you are the same way, you can just same applying 415 voltage. So now how to check the sensitivity? If the phase it is horizontal panel, you can do it both ways. Either you can short any phase to earth, either you can short any phase to earth, which means there will be flow of current only, there will be flow of current only from only this way. So this is in zone or before CT. If you short this if you short with a looping cable, then also it will flow and the relay will operate. Current will flow through relay, and it will operate. Or you can just change the just change the polarity of neutral CT or phase CT while shorting, while putting the earth switch. If you're changing the polarity, then automatically it will trip. Consider this case. Now we are going to check the sensitivity through just by changing the polarity of NCT. Changing polarity of neutral CT. Before S1 to here, I am going to put here S1 and here S2. So what here I am going to short with the earth. Then I have changed the polarity changed. So what will happen? The current, this will flow this side, so now I am shorting it with the I think there will be phase. So actually before what we have said, here the actual polarity is S2 is this side. So if current flows through this to like this, current will leave S2 since it is towards this path. Just I have changed the polarity, so this will flow through this side, and already this current is flowing through this side. So fault is created by changing the polarity, changing the polarity of NCT. So relay will sense it as in zone fault, and it will trip, and it will trip.